Hello and welcome to Doc Clay's chemistry lessons. Today's lesson is all about organic chemistry again, and in particular we're going to be looking at alkanes and alkenes. So, the purpose of the lesson is you should be able to do the following 5 things. So first of all, we should know what homologous series are. Secondly, you should be able to recall the general formula for the alkanes. Recall how haloalkanes can be made from alkanes. You should be able to recall the general formulas for the alkenes and name some simple alkenes and their reactions to make haloalkanes. Okay, so let's go and have a look. So, first of all, what is a homologous series? Well, a homologous series is a group of compounds that firstly have the same general formula. They have similar chemical properties. They have a gradation in physical properties, and they differ by CH2. So let's just have a quick look at a couple of these things. Chemical properties would mean things like, for example, they all combust, react with oxygen, similar reactions. A gradation in physical properties, what that means, the physical properties we mean is melting and boiling point. And if it's a gradation, well, that means it's going to increase with the number of carbons. Finally here, each one differs by CH2. So if I look at a set of homologous series here, this is methane, ethane, propane, and butane. Each one, as you go up, has an increase of CH2. So, we briefly looked at some examples there. We're going to look at some specific homologous series, and we're going to look at their general formulas. So here we have examples of homologous series. So the alkanes we've looked at already, they have the general formula CnH2n plus 2. So if we had 2 carbons, we'd have ethane, it'd be C2H. 2 times 2 plus 2 is 6. Or if we have propane, C3, 2 times 3 plus 2 gives me H8. Alkenes, which we'll be talking about a little bit later on, they have the general formula CnH2n, slightly different there from the alkanes, notice. So ethene would be C2H4. Propene would be C3, H6. And finally, the alcohols, which we will look at, and we're going to look at ethanol. So I'll just write that down. It's the only one we'll look at in GCSE. Ethanol, you might be able to tell, has got only single bonds, and it's got 2 carbons in the chain. And alcohols all have the same group in them, which is an OH. So there's our homologous series and the important 3 examples we'll be looking at this term. So now we're going to look at alkanes, and I've underlined the bit alkanes here. You might remember what that means. It means they're saturated hydrocarbons. They've got the general formula, remember, CnH2n plus 2. With saturated meaning there's only single bonds. And they will react with halogens. So the halogens are in group 7 of the periodic table, and they contain fluorine, chlorine, bromine, and iodine. But the problem is that the carbon-hydrogen bond is very strong. So in order to get them to react, we have to use a light source. And the light that we use is UV, which is a high energy light. That breaks a carbon-hydrogen bond, and then the bromine, the Br2 here, can react. And we make what we call a haloalkane. Now the halogen there is a bromine, so this is methane on the right. And if we make a haloalkane, we add the word bromo if it's bromine, chloro if it's chlorine, fluoro if it's fluorine, We make bromomethane. Spell that correctly. And we also have this product, hydrogen bromide, as the other product. If you notice, we've got 1 carbon on the left, 1 on the right, 4 hydrogens on the left, 1, 2, 3, 4 on the right. We've got 2 bromines here, and we've got 2 bromines, so it's all balanced. One of the bromines has replaced one of the hydrogens, so if you think about football, if you replace a player on a football pitch, this is called a substitution reaction. And it uses UV light. The homologous series is the halo alkane that it makes. Okay. So we're going to move now on to a different functional group, and it's got a different ending. If you notice up here, enes, so these are the alkenes, and they're different to the alkanes, so they all have the ending enes. Importantly, the alkenes are what we call unsaturated, and they're unsaturated because they have a carbon-carbon double bond, and they're unsaturated because you can add to this more atoms. So you can add hydrogen or you can add a halogen. How we name them is exactly the same. So if we have 2 carbons, then it's eth. If we have 3 carbons, well, we've got prop. If we've got 4 carbons, we have bute again. Notice there is no 1 carbon, because in order to have an alkene, we have to have a carbon-to-carbon double bond, and meth, well, there's not enough carbons. So let's look at naming these 3 examples we got here. Number 1, why don't you have a go at naming number 1? I'll give you a couple of seconds. There we go, well done. If you got this, 2 carbons, so it's eth, ene. Notice the ending ene. This time have a go at number 2. That's right, we count up the number of carbons as 1, 2, 3. That makes this prop. Ene. And finally, number 3, I'll give you a few moments. There's 2 here. Perhaps you might be able to name them and also see the difference. That's right. These are both, I'll write this underneath, bute, 4 carbons, ene, but they are slightly different. If you notice this one on the left, the double bonds between the second and the third carbon, the one on the right, the double bonds between the first and the second. So actually we name these slightly differently. They are isomers of each other. We call this one bute 2-ene, and this one bute 1-ene. Otherwise, our naming is pretty much exactly the same as we've seen with our alkanes, just the changing in that ending. So the final thing in today's lesson is to look at alkenes and their reactions to make what we call haloalkanes. So similar in reaction as we had before, where we've got the bromine from the halogens, which is, remember, group 7. So this could be fluorine, could be chlorine, could be bromine, and could be iodine in place of the bromine. And the reaction here with ethene, but it could be propene or butene, as we've seen already. They come together, and we get a product here where the carbon-carbon double bond opens up and the bromine is now incorporated into the molecule, and so we have two bromines in our product. We also now have a saturated compound because there's no carbon double bonds, they're all single covalent bonds. So this is now 1,2-ethane. We also have to name the bromines, so it's bromoethane. And we've also got two of them, so we call it dibromoethane. And finally, we also name which carbons they come on. So this is 1,2-dibromoethane, although you only ever have to name it dibromoethane at GCSE. Last time with the alkanes we had a substitution reaction, but this time we've only got one product. So this time the bromine is being added to the alkene, so as a result we call this an addition reaction. Now, you may also know that bromine has got an orange colour. So bromine is orange. The product in this reaction is colourless. So dibromoethane is colourless. And what that gives us then is a test for alkenes. And our test for alkenes is that orange bromine water turns colourless if an alkene is present. So that was the last part of our lesson. We'll have a quick review and see what we've done today. So we just got a quick review of the lesson. We've seen there, we know what homologous series are. We should be able to recall the general formula for the alkanes, recall how haloalkanes can be made from alkanes, recall the general formulas for the alkenes, name some simple alkenes and their reactions to make haloalkanes, and also, finally there, we've also looked at a test for alkenes. Okay, that's the end of the lesson. I'll see you soon.